Hi all, this is Eric, and in this episode we're gonna talk everything about the Midnight examples. These examples are provided by the core team itself for Midnight, so we're gonna understand how to build the code, what are the prerequisites to compile a code, build the code, understand the structure, and see how we can implement our first contract and run it and test it. All the documentation necessary for this series it's going to be stored on the Midnight repo under Mesh repository. So if you go to Midnight, you're going to find examples. And this series, we're going to talk about the Midnight examples version 0.2.0. So in there, under README, you're going to find all the links related to the documentation that we're going to see now on how to install the different softwares that are prerequisites to compile the code. For our examples, we're going to use Windows Subsystem for Linux version 2. We have listed all the procedures that we need to follow to make sure that we have Linux installed on our computer using Windows. So now let's go step by step and install Windows Subsystem in our computer. Okay, so let's start by opening PowerShell on Windows. Make sure to open PowerShell as an administrator. So the first now we're gonna follow all the commands that were shown previously. We first install WSL on our computer. This is gonna install the default Linux distribution. So we install it. Once we have installed Linux for Windows in our computer, we can check by following the next commands. This command is going to make sure to confirm if we have Windows for Linux installed on our computer. We have version number 2. We can confirm the path location of the Linux distribution, and then by pressing WSL, we can get into Linux. And then to see the final version, we can type release and we can confirm that we have version 2404. We are going to use Docker Desktop for Windows to run and host our Midnight instances and other third-party services instances. So just follow that link and download the executable. Once downloaded, we can check if everything it was installed correctly. Okay, now let's install Docker together. We follow that link provided. Once we are into that link, we click on that executable link. Once downloaded, you want to follow the procedures, and then you can operate the software of Docker. And once installed, you can go on settings and confirm that the WSL feature is enabled. The wallet that we're going to use to interact with the Midnight network is called Lace Wallet. I'm providing the link with the detailed documentation on how to install a wallet, but in the next video, I'm going to do this process so you can see it step by step. Okay, so in that link, we're going to find the executable of the wallet. So there's different versions. We're going to use 1.2.5. So we're going to download it. Once it's downloaded, we have to unzip it. So we're going to select the wallet and then we unzip. Once that we have unzipped the wallet, now we open the browser Chrome that is compatible with the Midnight wallet. And then we have to make sure once we enter the extensions management, we are in the developer mode. So at the top right, you're gonna see this toggle. You can switch it on and off, make sure it's on, and then we have to load the unpack version. We select the executable that we just downloaded and insert it into the executables. Then we can see that we have the Midnight extension installed. So now we can open it, put the password over there, and then we have our wallet over there and ready to be used. We have to wait for it to be synchronized. And once it's synchronized, we're gonna see that we have some T-dust in our wallet. There you go. In case you need to acquire some T-dust when you install a fresh wallet, there is a faucet. So we have to copy our receive address. So we open our Lace wallet that we just installed, and then we select the receive address. Once selected, we go back to the faucet. We paste for tokens. We want to have to wait between 1 and 2 minutes, and once that process is done, and once our wallet is synchronized, we're gonna receive 1,000 T-dust. Okay, so the process is done. We can see the transaction hash over there. So once we go back to our wallet, we can see that we already have those almost 1,000 T-dust that we had before when I show you how to install the wallet. But once the wallet is synchronized, we must have another 1,000 T-dust. So there you go. We have almost 2,000 T-dust. The IDE that we're going to use for this tutorial is VsCode. So if you want to follow with the same software that I'm using, you can follow that link with the documentation on how to download VsCode. Once we have VsCode installed, open it and make sure that you have connected to the Linux distribution. To make sure, you have to see at the bottom left message saying you are connected to WSL Ubuntu. Okay, now let's download the proof server in our machines. The proof server is responsible for creating the proof that Midnight uses to send commands to the node. The private information never leaves the user's machine, so the proof server receives those private information, creates a proof, and it actually sends that proof to the node. So we're gonna follow the steps provided in the documentation on that link to download the proof server. Okay, now let's follow the commands provided on the documentation of that link. We first confirm that we have Docker installed on our computers. We can see the version, and we are connected to the Linux distribution. So now let's start putting the commands and install the proof server. First, we search through the Midnight Network Docker ecosystem to see what are the instances available for us to download using Docker. We can see that we have a proof server. So we can download the proof server. We use this command to download one of the versions of the proof server. So we have to put a version over there. So to see what version we need, we can go to the Midnight documentation, and there is a compatibility matrix. So since we are using the latest version, we're gonna see over there that the latest version is 3.07. So now with that version, we update that command and we put over there 3.07 and we run the command. With this, we're gonna install the proof server on the Docker engine. We can confirm this by opening Docker and seeing that one of our images, it's over there. It's the Docker, it's the proof server 3.07. Now with this command, we can check the versions that were installed, and we can see there that we have a 3.07. Now, to run the proof server, we can use this command that is gonna run that instance on port 6300. So if we run the command, we can check that the Docker engine now has a container running on that port. To close that instance, we can press Ctrl+C to actually shut down the instance, and we can confirm now that the instance is shut down. Okay, now to demonstrate that everything is working correctly, we can send some tokens to ourselves. So let's open the Lace wallet and wait for it to sync. Let's confirm that we are in the tested network. The node address, it's the public address provided by Midnight. The proof server, it's our local instance. The indexer also is the public link provided by Midnight. Make sure to confirm that we are in the tested network. So now that the wallet has synced, let's start our proof server on the Docker desktop. We're gonna see the logs over there. So now let's send some tokens to ourselves. So we select our receive address, and we're gonna send to our same address, 1TDAST, just for demonstration purposes. So we send, and we have to sign the transaction. After signing, the wallet is gonna start working, and we're gonna create a transaction that needs a proof. So if we open the Docker desktop, we're gonna see that the proof server is working, and it's creating the proof. Once it's done, we're gonna see a log saying how much time it took to create that proof. Yeah. In this case, it took 29 seconds. So in the wallet, we can see that the transaction has already been sent to the node. So now it's showing that the wallet is syncing, and we have to wait for final confirmation. There it is. Now we are going to download the compiler that is necessary to develop contracts in Midnight. The compiler, it's called Compact, and it's considered to be a DSL, domain-specific language. So you write code in a specific syntax and format, and then the compiler transforms that code into TypeScript that is actually used within the APIs. This compact is where you actually write your circuits and your logic. Okay, so now let's download the compiler. So I'm in my Linux distribution. I'm gonna create a new folder that I'm gonna call my binaries. So I can check that this new folder was created, my binaries. So now let's check for the executable that I can download for the compiler. So in the compatibility matrix, I can see that the latest version of the Compact C, it's 0.22. So I go to the compiler page and I download the executable for Linux. Once we downloaded the executable, I'm gonna copy it and then I'm gonna paste it on Linux. So I'm gonna look for my folder that it's under home, Eric, my binaries folder that I just created, and I'm gonna paste it over there. Once I have it on Linux, I go to VS Code, and then I go to the my binaries folder. Once over there, I can now check that I have the zip file. So I'm gonna unzip it. Okay, now that I have unzipped the compiler, I'm gonna check that the compiler was installed successfully. I can check that it's installed, but now I also want to run it not necessarily within the folder itself. So I have to update my bash or C folder in Linux following those commands, the compat home and the path. So now if I refresh and run those export commands, I can run the compact C, which is a compiler, externally without having to be within the folder. Now we're gonna download the compact plugin provided by the Midnight team if you're using VS Code. This plugin highlights specific compact language features like keyword, string, and comments, and we're gonna use it when writing a smart contract using compact language. Okay, now we wanna download the plugin. So we go first to check what is the latest version of the plugin, which is 0.2.13. So we download the package. This package is already unzipped, so we just need to copy and paste it on a folder on the Linux distribution. So we want to paste it on the same folder that we saved the compiler in the first time. So we just paste it on my binaries folder. Once I have it over there, I can open the extensions on VS Code and then click install from V6. Then I have to select the folder that I have just saved the plugin, select that document with extension point V6. And then it says it has completed installing the extension. So now I can open the extension and write compact, and I can see that I have an extension named compact. And I can see the latest version that it's 0.2.13. Okay, now we're gonna download the Midnight examples in our computers. We're gonna need to go to the Midnight repository under Mesh organization, and then we're gonna clone that repository. We're gonna make sure that we have Node and Yarn installed, but that procedure I'm gonna showcase during the next video. Okay, so we are under the Mesh organization and the under Midnight repository. So now to clone it, just copy the link of the repository, and we wanna go to VS Code, and we wanna clone by writing git clone and putting that link that we just copied. Since I have already cloned it, if I press ls, I'm gonna see that I have a folder called Midnight, which are the examples. So by clicking cd Midnight, I'm gonna enter into that folder, and I can see that I have different folders inside the Midnight examples. I can see on my left as well how that repo is structured. So for this example, we're gonna enter into the Midnight example themselves. They are under the folder Midnight examples and midnight examples 0.2.0. We're gonna check that we have a version of Node 18. In case you don't have that version or you don't have Node installed, I'm providing the link necessary to install Node. In this case, we're gonna use NVM, which is the easiest way to install Node. So we copy the link and we just install NVM. Since I have already NVM installed in my computer, I can check that I have NVM and I have yarn installed by pressing the following commands. With NVM -- version, I can confirm that I have the version 0.39 of NVM. With Node -- version, I can see that I have version 18. If you don't have version 18, you can write NVM install, and automatically NVM is going to install the version 18th that is required for these midnight examples. Now you can check that you have yarn installed on your computer. In case you don't have yarn, you can type corpack enable, and yarn is going to be installed in your computer. And you can check by writing yarn -- version to see the latest version of yarn. Okay, perfect. Now we are ready to build and test examples. First, we're gonna build the repository, and then we're gonna run the examples. There are two projects inside the midnight examples. One is the counter example, and the other one is the bulletin board example. And with the counter example, we're gonna run it using tested remote configuration and a standalone configuration. And the same thing is gonna happen for bulletin board. We're gonna run it using tested remote configuration and a standalone configuration. Also, for the bulletin board, we're gonna run the UI. So we're gonna open our browser and we're gonna see the constructs using our browser and wallet. Okay, let's now build the project. Let's first make sure that we have the latest version of Node installed required for this example, which is version 18. Now, by running yarn, we're going to install all dependencies. After running yarn, we're going to have a folder called Node modules. All dependencies are going to be installed in that folder. Now we are using Turbo Repo in this repository to build all the workspaces. So by running npx turbo build, we're going to start building all the workspaces. That includes the counter and the bulletin board example. Okay, 10 successful installations were performed. So now we are ready to start testing and running the examples. We are going to first start with the counter example. So let's go to that folder. We copy the path of the counter example, and then we go into that folder. Within that folder, you're gonna see that you have a contract folder and a contract CLI folder. Under contract, you have to make sure that you have the output of the compiler after having done the compilation. Now to run the contour example, let's go to the contour CLI folder. And by looking at the package JSON of that folder, we're going to see that we have two ways of running this construct. There's other ways, but we're going to actually use two ways: the tested remote configuration and the standalone configuration. For these examples, make sure you have the Docker desktop open and you're running the proof server. We're going to start testing this contract using the testnet remote configuration. So by running yarn testnet remote, we're going to start testing this contract on that configuration. We have two options. We can build by creating a fresh wallet or by importing a seed phrase. So we want to choose option number one. So after running that command, we can see that we have created a wallet where the seed it's specified, and then we have also a wallet address. We have to copy this address of our contract, and we have to fund it. The way to do this is by opening our existing wallet that we have already requested some TDAST, and then we have to transfer some TDAST from the wallet that we have tokens to this new address that we just created for testing the contract. We are signing the transaction. Make sure you have the proof server open. This process normally takes between 10-20 seconds. We can see that we are processing, and the proof server is generating a proof. It took 23 seconds to generate the proof. And then we are waiting for our wallet to sync. Once it sync, it means that the funds have already been transferred. So back in VS Code, we are waiting for those funds to reach our wallet that we are using for testing this contract. Once we receive those funds, we wanna a message is gonna pop up saying, okay, we have received those 50 TDAST that we just sent. In this case, it's 50 millions because actually we're using other units, but it's these 50 millions, it's actually 15 TDAST as it's seen in the wallet. Okay, once we have deployed we have initialized our wallet, we can deploy a new contract or join an existing contract. In this case, we're gonna create a new contract. So we choose option number one. For this, a proof is gonna be created as well. And in this case, it took 10 seconds. So now we're just waiting for the transfer to be processed by the node. Okay, so a new contract has been created. We can see the deploy contract address. We can copy it in case we want to join that contract later. And now we have three options. One option to increment the counter, one option to display the value, and the other one to exit the contract. So let's see the current value of the counter by pressing option 2. We can see that the counter value is 0. So if we run the option number 1, we're actually going to run a circuit that increments that value. So if we choose option number 1, a proof, the proof server is going to create a new proof for that circuit. We can see that it's processing. And we can see that it took almost 11 seconds. So we just have to wait for it to synchronize. Okay, so we just received the transaction hash, means the transaction was successful. So now if we press option number 2, we're gonna see the current value of the counter, and we see that its value is it's 1, which means the circuit was run successfully. Okay, by pressing option number 3, we exit this contract. Okay, now we're gonna build this contract project using the standalone configuration. In this case, we're not gonna use the links provided, the instances provided by the Midnight team. Actually, we're gonna host and run those instances using Docker, and everything is gonna be deployed in our machines. So we close the proof server that we were running because we're gonna embed all these instances within this repository now, and we're gonna run a command to spin up all these instances all together. So by running yarn standalone, we're gonna spin up these instances, and by opening Docker, we can see that those three instances were initialized. So we can see the proof server, we can see the counter node, and we can see the indexer. We can also see all the logs from those instances. We can see that the wallet has already been funded. Since we're using a headless wallet, we are using a seed phrase that it's already configured, and once initialized, we already have those TDAS available. So now we choose option 1, and we're going to go through all the procedures that we went by using the testnet remote configuration, but now we're going to use the local configuration. So we are deploying the contract now. So we see that the proof server took almost 18 seconds to generate the proof. So once the contract has been deployed, we can see the address of that contract, and then we have those two options: increment the counter or display the actual value. The current value is 0. So if we choose the option number 1 to run the circuit to increment the counter, we can do that by choosing option number 1. By selecting this, again, we're gonna start generating a new proof. So if we open the Docker desktop, we can see that a new proof is being generated. In this case, it took 10 seconds to generate a proof. Once the transaction was submitted successfully, we can see the transaction hash. And then if we click option number 2, the updated value, it's 1 now. So the circuit was run successfully. Perfect. So now let's start the new example. Okay, now let's start building the other example, which is called the bulletin board example. So if we copy the path of that project and we go to that folder, we're going to start running that example. But first, we can see the structure, and we can see that we have some folders inside. Just to make sure that everything was built correctly, by going to the contract folder under managed bulletin board, we should see all the outputs of the compiler. Okay, let's go now to the bulletin board CLI folder. So we copy the path and we paste that path to make sure that we are under the bulletin board CLI folder. If we open the bulletin board CLI folder and we go to the package.json, we can see under that package as well that we have two ways of running this example, using the testnet remote configuration and the standalone configuration. So let's first start running this project by opening Docker Desktop and make sure that you have the proof server running. So now run the command yarn testnet remote. For this contract, again, we have two options. Build a wallet from fresh, a fresh wallet, or build a wallet from an existing seed phrase. So in this case, we're going to build a fresh wallet. So we choose option number 1. In this case, we created a wallet and we have a seed phrase and we have a wallet address. Again, since this is a new wallet, we have to fund this wallet. We can fund it by using our existing wallet that we already have TDAST and send some TDAST from our wallet in the browser to this new wallet that was created for the bulletin board contract. So we paste the address and we sign the transaction. Make sure you have the proof server open and running, because for sending transactions, you also generate a proof. So you can see that the proof server is generating a proof for this transaction. And it took 22 seconds. Now we're just waiting for the wallet to be synced. And once it's synced, we're going to see that we have received those funds in our new wallet. So we just have to wait. There you go. We just received 50 TDAST. It says 50 millions, but it's actually 50 TDAST. So now, once we have our wallet funded, we have two options. We can create a new bulletin board contract, or we can join an existing bulletin board contract. In this case, we want to create a new contract. So we choose option number 1. For this, again, a new proof is going to be generated. So we open the Docker desktop, we're gonna see that a new proof is being generated. And in this case, it took almost 10 seconds. We are just waiting for the CLI to update the information that just got processed. And we can see the contract address being displayed. And now we have 6 options. One is to post a message, another take down your message, another one to display the current ledger state, known by everyone, then display the current private state, and another option to display the current derived state. This is just known by you, and another option to exit the contract. So to start testing this contract, we're going to start posting a new message. So we choose option number 1. Then an option to write a message is displayed. We're going to write hello all, and we send the transaction. So again, the proof server is going to start working, and it's going to generate a proof. And it took almost 10 seconds to generate a proof. So now we just have to wait for this transaction to be processed by the node and be displayed on the CLI. There you go. The post message was just submitted. So if we take a look at the ledger state, we can see the updated state of the contract. By choosing option number 3, we can display the current ledger state. We can see that the current state is occupied. The current message is hello all, the message that we brought. The current instance is 1, and then we have the current poster, which is the hash of the current user. If we choose option number 4, we're gonna see our current secret key. We actually get to see this secret key because it's available within the client computer. If we choose option number 5, we can see other information like the current state, the message, the instance, and some custom messages that can be generated. So now let's try executing a new circuit, which actually takes down the message. So if we choose option number 2, we are gonna run and execute this circuit. And again, if we open the Docker desktop, we're gonna see that the proof server is generating a new proof. In this case, it took almost 10 seconds. So now this proof is gonna be sent to the node and it's gonna be processed. We are just waiting for the transaction to be processed and be shown on the CLI. Okay, the circuit was processed successfully. So now if we run again and see the current ledger states, by choosing option number 3, we can see that the state now it's vacant. The current message is none. The instance is 2, and we can see the hash of the current poster. By choosing option number 4, we can see the secret key that hasn't been changed. And with option number 5, we can see that the state is vacant, none, the current instance is 2, and the current poster is not due because actually the the state of the bulletin board is vacant. By choosing option 6, we just exit the contract. Okay, now we have already tested the bulletin board example. Let's run it now using the standalone configuration. For this, we're gonna close the proof server because we're gonna run it using the Docker compose command. So under the bulletin board CLI folder, let's run yarn standalone. We're gonna spin up 3 instances. If we open the Docker desktop, we can see that we can confirm that those instances were started. We can see the node instance, the proof server instance, and the indexer instance that were spin up successfully. We can actually see the logs as well from the proof server. In this case, since we are using a local configuration, we are going to be provided by a wallet that it's already been funded. So we can go straight away deploy a new bulletin board contract. If we choose option number 1, we're going to start the deployment procedure. So we see that the proof server started to generate a proof. It took almost 18 seconds to generate this proof. And now that proof is being sent to the node, and we just have to wait to be updated on the CLI. There you go. A new contract has been deployed, and we can see the contract address, and we can see those options again. So we're going to follow the same procedure. We're going to start posting a new message. We can write a message. We're going to write hello all. And then we start securing that circuit. Again, the proof server is going to start generating a proof by opening the Docker desktop and see the logs of the proof server. We can see what the proof server is actually doing. Depending on the circuit, this might take more time, and it's going to depend also on the resources available on your computer. So we can see that the proof server is working, generating all that proof.
Yeah.
The proof was already generated. So now we can see the current ledger state by choosing option 3, 4, and 5. With option number 3, we can see that the current state is occupied. The message is hello all, the instance it's 1, and we can see the current poster. With option number 4, we can see the current secret key. And with option number 5, we can see some additional information like the current state and some custom information. Okay, now let's run the other circuit, which it's gonna take down the message of the contract. So by choosing option number 2, we're gonna start running that circuit, and we can see that the proof server started to generate a new proof. Again, this might take a few seconds, so we just have to wait for the proof server to do its work. We can see the logs of the proof server. what it's actually doing. Sometimes the proof server stops showing the logs when it starts generating the proof. When that happens, you can close the Docker desktop, open the desktop again, and start running the proof server, and everything is going to start working again. Okay, so the circuit was executed successfully. So now we can take a look at the current ledger states again. By running option number 3, we can see now that the current state is vacant, the current message is none, and the current instance is 2, which means that the circuit was run successfully. Now with option number 4, we're gonna see the current secret key, which is the same, it hasn't been changed. And with option number 5, again, we can see the current states, the message, the instance, and some custom information. Perfect. Now with option number C, we exit the contract, and now we have successfully tested these two examples using the CLI. For the bulletin board example, there is another option to test this contract using a user interface. So for this, we can go to the bulletin board UI folder. We're gonna copy the path and make sure to go to that folder. You can do that by opening your the VsCode and writing CD and clicking and copying the link of that folder. So now we are under the bulletin board UI. If we go to that folder and open the package JSON, we can see that we have options to start the HTTP server and an option to build the code. The code has already been built running Turbo, so we just need to run the start command. If you go to the main file, make sure to have this configuration as displayed. Since we're going to be using the testnet network. Okay, so now for running our server, we're gonna use the command yarn start. So the server, we're gonna be able to talk with the server and see the UI by going to that link. Again, make sure to open Docker desktop and run your proof server. So if we go to that link, the UI can be shown. Make sure that you have your wallet connected. You have some T-Dust. The wallet is sync. Under settings, we can confirm that we are using the testnet network. And the links are being provided. The node address, this is the public link provided by Midnight. Under proof server, we have the link where our actual local proof server is running. And then under indexer, we have the link provided by Midnight that it's an instance being hosted by them. Okay, so now we are ready to start testing this contract using the UI. So we can create a new bulletin board. We are assigning a transaction. And we can see that the proof server is generating a new proof. In this case, I'm having the same issues with the proof server. So what I'm gonna do is just close the doc engine and run it again. There you go. A new contract has been published on the blockchain, and we can see that now we are available. We're able to write a new message. If we type "hello all" and send this transaction, we're gonna be asked to sign the transaction, and a new proof is gonna be generated. We had a network ID issue that it's saying that we are talking with the undeployed network when it was expected to talk with the test network. When that happens, we can go back to the bulletin board UI, make sure that we're running the Node version 18. And if we go to the main file, make sure just to write again the testnet. So under network ID, we're gonna have different options. Make sure that you have selected the testnet option. And now we have to build this code again. We don't need to build the whole repository, so just build the bulletin board UI by running yarn build. Okay, now that it's been built, we're gonna start the server again by running yarn start, and we're gonna test if we are able to run the contract. Okay, so I paste the link, and we're gonna start again. We make sure that our wallet is synced, and we first create a new bulletin board. We sign the transaction, and we see that the proof server started generating a proof. A new proof has been generated. It took almost 11 seconds. So now we just have to wait for the proof to be sent to the node and our UI catch up with the indexer. There you go. A new bulletin board was created. So now we have the contract address and we have the option to post a new message. So we can write a new message. We're gonna write hello all from the browser. Make sure our wallet is synced. So now we can run the circuit. So in this case, we are running the circuit to post that message. So we're gonna be asked to sign the transaction again. We're gonna sign it with our wallet. And the proof server is gonna start generating a proof. It started to process, and it took almost 11 seconds to create a proof. Once the proof was generated, this proof is going to be sent to the node. And again, once the indexer catch ups, our UI is going to display the new message. There you go. So now we have the option to erase that message from the bulletin board. Again, we press the option to erase. We're going to have to sign a transaction. We sign the transaction using our wallet. If we open the Docker desktop, we can see that the proof server started to generate a proof. It took almost 11 seconds to generate this proof. And again, this proof is going to be sent to the node, and we're going to have to wait for the indexer to send the updated information. There you go. The bulletin board has erased the message. So now a new user can post a new message. There you go. We have tested these two smart contracts, and we can close the contract by pressing Ctrl C. With this, we conclude this first episode, which its goal was to build and run the Midnight Examples repository. For another episode, we're going to see more in detail how this repository is its structure, and we'll understand the code that are inside this repository. See you next time.